This video is going to be a third example of how to calculate the derivative using algebra. This one's going to be a little bit trickier, but it's not going to be all that tricky at all. It's just going to fall to the same techniques we've been using up to this point. All right, so this time our function is going to be f of x is equal to 2x squared. And we want to calculate the derivative of this function at 1. Same starting out point. We want to start out with the limit as x approaches 1 of f of x minus f of 1 over x minus 1. We're going to substitute our values into the function. So this is the limit as x approaches 1. F of x is equal to 2x squared. And if I substitute 1 into this equation, I get 2 times 1 squared. Well, 1 squared is equal to 1. And so 2 times 1 is equal to 2 over x minus 1. Well, I can factor this out a little bit. Limit as x approaches 1 of 2 times x squared minus 1 over x minus 1. And we've done this with quadratic functions before, but what I'm going to do is I'm going to factor this numerator, because that's the difference of 2 squares. So x squared minus 1, I'm going to write that as x minus 1 times x plus 1. And then that lets us cancel out the x minus 1 from the numerator and denominator. The limit as x approaches 1 of 2 times x plus 1. And now we can just substitute 1 in for this. So that's 2x plus 1 is equal to 2. And 2 times 2 is equal to 4 for our final answer. All right, now let's try this again with the second definition. So f prime of 1 is equal to the limit as h approaches 0 of f of h plus 1 minus f of 1 over h. So this, substituting h plus 1 in for our value here, remember, all we're doing is h plus 1 is our input, so we're going to substitute that in for x. So this is 2 times h plus 1 squared minus f of 1. Over here, we saw that f of 1 was equal to 2, so we'll just repeat that. All right, now we need to use a little algebra to multiply out this binomial. So 2 times h plus 1 squared. Well, h plus 1 squared is h squared plus 2h plus 1 minus 2 over h. You can verify this using FOIL or using the box method. But remembering, just knowing how to multiply out binomials like this is probably a good technique you want to get used to over time. The limit as h approaches 0 of, I'm just using the distributive property now, plus 4h plus 2 minus 2 over h. And the positive 2 and negative 2 are going to cancel out. So the limit as h approaches 0 of 2h squared plus 4h over h. And what you'll see, you can do this in 2 steps if you want to, or you can just do it in a single step. Notice that both of the terms in the numerator have a factor of h in it. So I could just cancel out this h from both of those. All right. If you want to make an extra step as you're writing out your work, you can write this as h times 2h plus 4 over h. And then here you see that the two h's cancel each other out. Or if you prefer, if you're comfortable with it, you can cancel out the h from both of the terms and do it like that. But in either case, this is equal to the limit as h approaches 0 of 2h plus 4. And once again, now that we've gotten rid of the quotient here, we can just substitute 0 in for h. And so that is 2 times 0 plus 4, which is just equal to 4. So you see we got the same answer of 4 either way. And so looking over these two techniques, what you see is that this technique, it took me less work to write it out, but I needed to know this factoring. I needed to know how to factor this into these terms. Over here, I had to evaluate this algebraic expression. But then once I was doing that, it was just a load of algebra. And this might have looked like it was a great big coincidence that our +2 and -2 canceled out here, and that what we were left with, everything had a term of h, so we could cancel out an h. But as you do these for more complicated functions, you're going to see that this is always the case. So this will always work out when you're calculating a derivative like this. And so we get through these steps, and then we've got something where we can just substitute 0 in for h, and we get our answer of 4. All right, so that was a slightly more complicated example, but the idea is one that we're going to carry with us for the rest of this calculating derivatives. So it might take you a little bit of paper. It might take you some practice with these more complicated examples, but the basic idea of what you're going to be going through is very much like it is in this problem for the more complicated functions you're going to be calculating in this upcoming IXL.